The distributive property is super important when we get to algebra. We can use the distributive property to do two things, and they're both directly related to each other, or should I say inversely related. The first thing we're going to talk about is how to factor using the distributive property. And distributive property is all about creating equivalent or equal expressions. And equivalent expressions look different, but they have the same value. So, for example, if I have two rooms in my house, let's say that's represented by this first large rectangle. The green is the carpeting in my bedroom, the blue is carpeting in the living room. If I want to find all the carpeting that I need, I want to go to the store and I need to know how much it's going to cost. So it doesn't matter what color the carpeting is, I just need to know how much total carpeting in both rooms. So what I would do is I would find the area of the green room, let's call that the green room, it's the bedroom, and the area of this would be 2 times 3, which is 6 square units, and if we're talking carpeting, it's 6 square feet, or it could be 6 square yards. Now, here, if this vertical side, we can call it the length, we can call it the width, of this green rectangle is 3, that means the opposite side is also going to be 3. And to find the area, because again, let's remember area equals length times width. To find the area of the blue, we would do 4 times 3, which would be 12 square units. Okay? And because this is math class and not the carpet store, I'm interested in the expressions, in how we went about finding it. Because I'm not going in and saying I want 6 square units and 12 square units. I'm going to add these together, right? And 6 plus 12 is going to be 18 square units. Okay, how would I write this using expressions? Well, I'm going to switch the order and you'll see why in a minute. So for the green room, I have 3 times 2. And for the blue room, I would have 3 times 4. Now, I could put parentheses around this, but I'm not going to because order of operations says that we're going to multiply first. So the parentheses would not change anything. Now, that's one way to look at it, okay? That's the way to look at it as 2 separate rooms, and then I'm going to add them together. The other way is the way I'm thinking about it just as cost. If I want to look at this as one big rectangle, not differentiating between the colors of carpeting, but just thinking about the price, can you see that I'm looking for the price of an area that is 3 by 2 plus 4, right? Because that's the whole length or width, whichever way you look at it, of the large rectangle. And if I wanted to do that, I would do 3 times 2 plus 4. Okay, are these equivalent? Let's see. We have 3 times 2 plus 3 times 4. And then on the other hand, we have 3 times 2 plus 4. Okay, so this again is going to be 6 plus 12, which is 18. And then we have parentheses first over here, 2 plus 4 is 6. And 3 times 6 is 18. And since these are equivalent, these expressions are equivalent. Okay, and you could say, well, you know, what do I need distributive property for? Why do I need equivalent expressions? However I look at it is going to be fine. You use order of operations, you get the same answer. Well, let's look at this case, this more algebraic case in the second rectangle, where we have this green part of the rectangle is a W. Well, we don't know what that is, and guess what? No one's going to tell us right now what that is. Okay? So what we're going to have to do is we're going to have to write an algebraic expression instead of a numerical one, and we're not going to end up with an answer. Okay? So let's look at this. So the area of the green would be 3 times W, or 3W, right? And then the area of the orange would be 3 times 4, which would be 12. And I'm going to write that over here, and that would be 3 times W plus, because remember I'm adding the areas, 3 times 4. Okay, and now we see where we are going to factor out to create an equivalent expression, and this is how we're going to do this. We're looking at the factors of the two terms, okay? So we have 3 times W plus 3 times 4. Okay, I'm going to use my upside down division. What do these two have in common? It's quite easy when we leave it in this form. They have a 3 in common, so I'm going to pull that out. And what I'm left with is 3W, or 3 times W, divided by 3 is W. And 3 times 4 divided by 3 is just 4. And I'm going to bring down the plus sign. That doesn't look like an expression, does it? Well, what I'm going to do to make it an expression is I'm going to put the parentheses around W plus 4. And I'm going to bring down the 3. And so what I know is that 3 times W plus 3 times 4 does equal 3 times, I'll use the dot, W plus 4. These expressions are equivalent. This is what we call the factored form, and this is what we call the expanded form. And we're going to be doing this in algebra, but we're not going to be using models. So we're going to use our upside down division to do problems like this. And they're going to start to look a little different. So let's take a look. Let's see. What if I have something like this? 4n plus 10. Okay? Now, it looks a little different than the other one, but we're still looking for common factors to pull out. And we're still going to be using upside down division. Well, 4n is really 4 times n. But what do 4n and 10 have in common? They have a 2. They're both even, correct? So 2 goes into 4n 2n times. We're not pulling the n out, so the n stays there. Okay? So 2 times 2n would be 4n. Plus, how many times does 2 go into 10? It goes in 5 times. Now I'm looking and I see that 2n plus 5 have nothing in common. They don't have the 2 in common, right? And so then I'm done. And all I'm going to do is bring down, put parentheses, and bring this down. Okay, let's do another one. Let's do 33 plus 9x. Okay, well, there's an x only in one term, so they don't have an x in common. But I see that they do have a 3 in common. 3 goes into 33 11 times. 3 goes into 9 3 times. I didn't pull the x out, so it stays. Keep the plus sign. Bring down the factor that we pulled out. Okay, and that shows us that 33 plus 9x is equivalent to 3 times 11 plus 3x. Okay, one more. Let's do 12t squared plus 18t. That looks a little different, right? Well, let's see. Let's look at the coefficients first. The first thing I see is that they have a 6 in common. I'm going to pull out the 6. 6 goes into 12 two times, so that's going to be 2. I haven't done anything with the t squared, so that stays. Plus 6 goes into 18 3 times, and I haven't done anything with the t, so that stays. Now let's look at this. 2 and 3 don't have anything in common other than 1, but look, both of these terms have a t, so I'm going to pull out the t. And I want you to remember that 2t squared is going to be 2 times t squared. And t squared itself is t times t. So ultimately this is going to be 2 times t times t. Okay? And if I think about it like that, if I take out one of these t's, I'm left with 2 times t. So that's going to be 2t plus, if I take 3t, that would be 3 times t. If I pull the t out, I'm left with just 3. Okay? Well, I don't want to do that because now I'm done. Now 2t and 3 have nothing in common, so I'm done. I'm going to put my parentheses around it. And now, what am I going to multiply it by? Well, I'm going to do just like I would if these were numbers. I'm going to multiply the two factors together, 6 times t. That's going to be 6t. So my equivalent expressions are 12t squared plus 18t equals 6t times 2t plus 3. And that's the way we factor with the distributive property using upside down division.